very nice question we have. S is given to you is a set of three tuples. Okay, each element is a real number, and this is happening for all xy in this set. Okay, so that means xy is not zero. That's all they are telling you. Okay, now what happens? Okay, when you look at this expression, okay, what do we recall? I'll write in the margin. Just see if you recall that. You recall that if when we were learning quadratic equation, that if you have a x square plus bx plus c, when is this positive all the time? Do you recall that? It looks like this, right? If it is positive, if this is my x-axis and you know that it's positive all the time, it looks like that, hanging up. It is not touching the x-axis. Okay, number one thing you recall is that your a should be positive, then only you have upward facing parabola. And number two, you recall that you are not touching the x-axis. That means you have imaginary roots, meaning discriminant is lesser than 0. Okay. Now, what do we see? We see this is not looking like what we had, right? So what can we do? Make it look like that. So I can divide by x square or y square. Let me divide by x square. Okay. So I'm going to divide by, or let me divide by y square. It will look be easier. Okay. Divide by y square. So it will look like x upon y whole square plus 2b x upon y plus c, right? I'm dividing by y square is greater than 0. Now, does it look like that? Yes. Instead of x, you have x upon y. That's all the difference. So, what do we get? We are getting condition in ABC. Okay. So, such ABC are going to be in the set S, who will satisfy the two condition. Number one condition is A is positive. And what is condition number two? What is the discriminant here? B square. So in place of b, I have 2b. So b square minus 4 times a times c. I want this to be lesser than 0. So 4 gets cancelled. I get b square is lesser than ac. Okay, so these are the two conditions you have. Okay, any ABC who will satisfy these two conditions will lie in the set S. Okay, now let's start answering the questions. Which of the following statements are true? Focus on A. So is this element in S? So what do you think? Yes, A is positive because 2 is positive. Number one condition is holding. First term is positive. Number two, B square. Okay, what is B square? 7 by 2 whole square. Is it less than A times C? Yeah, let's check. What is this? 49 upon 4. Is it less than 12? I'm checking. Okay, is it less than 12 or not? What do you see? This is 12 point something more than 12, right? It is not lesser than 12. It is not lesser than 12. Okay, so second condition is not holding. So this is not an S. Yes? Okay, let's move to B. Now, if this is an S, that means this should be holding. Try to answer that. Okay, again, first conditions is holding. That means A is positive, 3 is positive. Okay, now second one, B square should be lesser than A times C. What do we get from here? B square is lesser than 1 by 4. Okay, or 4b square is lesser than 1. We take the under root. What does that mean? When you take under root, you get a modulus. Okay, modulus 2b is lesser than 1. Absolutely correct. Okay, so what B option to be correct? Okay, let's focus on the C part now. So what is the C saying? For any given ABC in S, the system of linear equation has a unique solution. Recall something from system of linear equation? Determinant of the coefficient matrix, if it is not 0, then it is going to have a unique solution. What's the determinant? Quickly, AC minus B square. Okay, that's the determinant. So AC minus B square, is it 0? Never, right? You just now said that your AC is greater than B square. Okay, so this is not 0. So again, yes, it has a unique solution. Okay, answer the D part also. What is D saying? Again, is this linear system of equation having a unique solution? What do we do? What is the determinant here? A plus 1 times C plus 1 minus B square. Now I have to check if this is 0 or not. Okay, let's multiply. AC plus A plus C plus 1 minus B square. Let's club the two things up because I know what is this, right? So I can write AC minus B square. I know AC minus B square is positive, right? Okay. Rest is plus A plus C plus 1. What can I say about the rest of it? Okay, because I know this is positive. Rest, you said A is also positive, right? Yeah. So A is positive. Okay, can I say C is also positive? Yes, because AC, the product is positive. Okay, B square, it is greater than a positive number. So AC is also positive. Okay, AC is positive. Okay, A is positive, then C is also positive. Everyone is positive. So no doubt this is never equal to zero because everyone is positive over here. So you have a unique solution again. Excellent question. See you with another one.